This is the video for section 6.3 notes, slides 24 and 25. All right, so in section 6.3, we are still solving a differential equation. But the problem is that when we have dy dx, there are multiple variables, both x and y, in the differential equation. And so this is a little different than what we've had in the past. In the past, we had dy dx, and there was only x in the equation. Now we have to think about having some sort of separation between those variables. And so what we have to do is not only do we have to multiply by dx, okay, that's what we've been doing, but now we actually have to bring whatever y's are on the right side to the left side. So in this problem, I would multiply by dx, and then I would divide by y squared to separate the variables. So that means I have dy over y squared equals 3x dx. And so now it's just like the earlier differential equation problems we have. But now when we integrate, we are not just going to get y on the left side. So on the left side, how do I integrate dy over y squared? Well, I would probably rewrite that as the integral of y to the negative second dy. All right. And on the right side, of course, we could just say, well, this is 3 times the integral of x dx. All right, so on the left side, the integral of y to the negative second dy is, well, remember, add 1 to the power, y to the negative first over negative 1. Right? And then, of course, we're going to add c. We only need to add it in once. All right. And so I get the integral of x is x squared over 2, and then, of course, plus c. All right. So now this is a general, okay, it's a general solution, but it is implicitly defined. We don't have this explicitly solved for y. All right. But we are told that if y equals negative 5, when x equals 1. So now that information is given to us to help us find the value of c. And so I'm going to put that information in. So I have negative 5 for y to the negative first over negative 1, or just put a negative in front, equals 3 halves times x equals 1 squared plus c. All right, so negative 5 to the negative first. What does that really mean? Well, we've got the negative in front. Negative 5 to the negative first means 1 over negative 5 equals, this is 3 halves plus c. And so remember, this is just positive 1/5. So I'm going to subtract 3 halves. So I get c equals 1/5 minus 3 halves. All right, so 1/5 minus 3 halves, that would be 2/10 minus 15/10. And so c is going to be negative 13/10, not 12ths. Negative 13/10. All right, so what does that mean? Well, that means that y to the negative first over negative 1 is equal to 3 halves x squared minus 13/10. Now, this looks great, all right, but we want to be able to solve this explicitly for y, okay? So when we say solve the differential equation, generally speaking, we're saying find what y is equal to, right? And so in order to do that, I actually have to solve for y. So we realize, or we remember, that if I have y to the negative first over negative 1, right, I can multiply by negative 1. That's easy. And what is y to the first? It's really 1 over y, right? So I get 1 over y equals negative 3 halves x squared plus 13/10. All right, so that's easy. But then how do I solve for y here? Well, it would really be like, taking the reciprocal of both sides. Now, the way we really can think about this is if I were to multiply both sides by y, I would have 1 equals y times that, and then I would have to divide everything by that. In other words, I get y equals 1 over negative 3 halves x squared plus 13/10. Okay, so if I have 1 over y, I just solve for y by taking the reciprocal of both sides. Now, the common mistake is people just say, oh, well, that would mean negative 2/3 x squared plus 10/13. No, the reciprocal of the right side is 1 over that whole thing, which is what we got here. So that's solving differential equation with that separation of variables. All right. And so really, there's just a little bit of algebra at the end. Not that bad. All right. So let's go on to slide number 25. All right. So same idea here. We have to separate the variables. So I have dy dx equals 4x over y. So I'm going to multiply by dx, and I'm going to multiply by y. So I get that y dy is equal to 4x dx. All right, so once the variables are separate, I've got all the y's on the left, all the x's on the right. I integrate both sides. All right, what is the integral of y dy? It is y squared over 2, right? And then, of course, plus c, but I'm going to put the plus c on the right side. What's the integral of 4x dx? That would be 4x squared over 2, or 2x squared. And then don't forget about plus c. All right, so now, in order to find the value of c, y equals 5, x equals 0. So 5 squared over 2 equals 2 times 0 squared plus c. All right, so 5 squared over 2, that'd be 25 halves, equals 2 times 0, that's 0. So c is 25 halves. All right, so that means that y squared over 2 is equal to 2x squared plus 25 halves. All right, so once again, this is the specific solution to the differential equation, but it is once again implicitly defined, right? So you have to remember there's two different things. We can have an explicit solution, which is y equals. We can have an implicit solution where y is not specifically solved for. Then we can have a general solution, like over here where we have plus c, and then we can have a specific solution. So this is a specific solution, but it is still implicitly defined. So we want to make sure we are able to solve explicitly. All right, so I would multiply by 2. That's pretty easy. Y squared equals 4x squared plus 25, right? So I multiply by 2. Now, when I square root to get rid of that, I get y equals, now keep in mind, plus or minus the square root of 4x squared plus 25. Now that looks great, but the problem is that this is actually two equations, right? This is y equals the positive square root of 4x squared plus 25, and y equals the negative square root of 4x squared plus 25. But we only want one answer. So which answer? Well, if I look, when x is 0, right? So if I plug 0 in, I get 4 times 0 squared plus 25. Square root of 25 is 5. So is it positive 5 or negative 5? Well, the answer is positive 5. So my specific explicit solution is the positive square root of 4x squared plus 25. Had this been when y is negative 5, x equals 0, then we would, of course, selected the negative. All right, so that is slide 25.